Here is a quick reminder. Always take the time to check your dashboards because, hey, sometimes they can reveal some interesting information. In today's video, we are going to walk through how I investigated a random spike in outbound traffic that was clearly not normal. Just as an FYI, this does take place inside of the SOC simulator in the MyDFIR SOC community. So if you want to practice with real enterprise tools, get community feedback, and experience what it's like to work as a SOC analyst, check out the link down below or head over to school.com/mydfir. Let's get into it. So the other day, I was taking a look at my metrics and I noticed a huge spike in outbound traffic sourcing from our domain controller. What I decided to do was create a post here in the community to allow you, the members, to investigate and see if you were able to identify what had caused the spike. Now, I do see Mohammed went out and created his own investigation, which is perfect. I was taking a look at the report and it's pretty good. I love it. So great job to you, Mohammed, and continue building up those solid reports. I did mention inside of the post that you do have access to Sysmon data via the Windows event table and the Windows event logs via the security event table. I gave you the date and time of interest, which was on August 26th, around 1 a.m. UTC time. In terms of the outbound sent, it was about 712 megs, whereas the normal usage is about 50. So if we take a look at the graph here, we can see a big spike right there. And that is essentially our objective. We want to determine what had caused this spike. And this is how I would investigate it. The first thing that I would do here is obviously head over to our security.microsoft.com dashboard and then begin with our investigation. We know for a fact that the time was around 1 a.m. and this was on August 26th. I'll go into the investigation and response, go over to hunting, and then advanced hunting. Again, there were two tables that was mentioned, the security event table and the Windows event table. And if I take a look under the schema and scroll down, I can eventually find Windows event under Microsoft Sentinel and security event under security and audit. So I'll go ahead and double click the security event. For the last 24 hours, I'm going to change this to last 3 hours. That way I can kind of get a hint as to what information I can find under this table. I'll go ahead and full screen this. That way it's a lot easier to see. And now we can take a look at the columns that exist. We have time generated, the account type, computer, event source name, channel, etc. What we're interested in here is the channel itself, because right now it just says security. But what if there are different channels within this particular table? What I can do is create a KQL just to show me all of the different channels within this particular table. And my objective right now is just to figure out what logs exist, right? We need to understand what we can utilize to eventually identify what caused that outbound traffic. Now, maybe Windows event logs won't give us anything interesting yet, but it is always a good idea to understand your data. So I will type in a pipe here and I'll say summarize count. Now you don't really need the count, but I'm just going to count it anyways by channel. And remember, it is still last 3 hours. So what I'm going to do is just change it all the way to the last 30 days. Currently, it is ingesting security event logs, system event logs, and Windows Terminal Service, aka your RDP logs, your remote desktop protocol logs. What I can also do is add in the computer name. And I am also going to remove the count because I don't need that. So I'll just remove this right here. Summarize by channel, comma, computer. And if we take a look, here are the endpoints that are ingesting these logs into this particular table. So we have our domain controller, PC1, 432. There's our contractor PC and contractor PC2. Now let's do the same for our Windows event table. And it is currently the last 30 days. So let me stop that. And let's do maybe last 3 hours. So right now we do see that the provider is Windows Sysmon. The channel is Windows Sysmon as well. Similar to what we did before, I'll just summarize by channel. And we can see that within the last 3 hours, it was all Sysmon. If I change it to last 30 days, is it still all Sysmon? Yes, it is. So what this tells me is that this particular table Windows event only contains sysmon data. And if I were to add in the computer, I can see that there is a computer here called MyPC that logged sysmon data once upon a time, and also the domain controller. All right, now that we know that, we can start investigating what had caused that outbound traffic. Let's just say that I am not entirely sure what to look for. I just know that we are interested in network-related logs, and I don't know if sysmon or the event logs that we found out earlier contains any information regarding network. What we can do is ask ChatGPT, does sysmon events or Windows event logs, now make sure we specify, we had security, system, and it was local session terminal, contain any network events. So ChatGPT is telling me that event ID 3 will contain some network events, and it says sysmon only logs outbound connections by default. It includes the source and destination IP addresses, source and destination port, protocol, process ID, and the user account. What about our Windows event logs here? So it says that 4624, successful logins might include that. 4625, your failed logins. 4648, a login was attempted using explicit credentials. And then we have 5156 and 5157, which are related to the Windows host firewall. And if we look at the system log, not typically used for network events. Okay. Terminal service, it logs RDP activity. And these are the event IDs or the relevant event IDs. So what we can do here is put that all into our notes and then begin with our investigation. The one that I am most interested right now is the sysmon event ID 3. So let's jump back over to our Microsoft Defender portal here. And our sysmon event is under the Windows event table. So let's go ahead and modify our query. And I'll add in a where event ID equals 3. And we want to zone in on the time of interest. So right now it is last 30 days. We do not need that. We are only interested for now in the date of August 26 at 1 a.m. UTC. So how do we modify our query? Well, I can put in another pipe and say where time generated, okay, I can't spell it, generated. Okay, there you go. Where time generated, and I'll use between date, time, and now we can put in quotes 2025, whatever our date of interest was. So in this case, I'll just say 260000. Date time again, and let's do 2025, August 26, and I'll do 0200. That way I can see 2 hours worth of data. Go ahead and hit run query. And here we go. Now we can start with our investigation. There are a total of 1,519 events. Now, if we take a look at the columns, we do see time generated, provider, channel, computer, task, event level name, event ID, system user, and version. But we can't really see any source IPs or destination IPs. Where is that? Well, if we go ahead and just click on the first event from the top over to the right-hand side, if we scroll down, we can start seeing that, hey, under the event data field, there is actually a source IP. And then there's also a show more. So if I click on that, there is also a destination IP, destination port. So these are the fields of interest that we want to see, but it's not in this column. So what do? Well, we can actually bring this out. And to do that, we can just expand the event just like that, scroll down until we see event data, expand that again. And now if we scroll down to our field of interest, we can just right click the field value and then extend column. Now at the top, it automatically added a query for us. And if we rerun this, scroll all the way to the right, look at that, we get our event data underscore source IP. So that is how we can customize and add additional columns. Another way of doing this is using project, and I'll show you. So we can hit enter here, and I'll enter in a pipe, and I'll use project because what this will do is select and display the columns that I want. So for example, if I type in project time generated, run that query, the column will only show time generated. But in my case, if I wanted, let's say my source IP, what I can do is actually just type in event data dot source IP. And there it is. Now, what if I want a destination IP? Well, just type in event data dot destination IP. And there is my destination IP. Just be wary that these field names are case sensitive. What I mean by that is that if you take a look at my IP, the I is capitalized, but the P is lowercase. Now, what happens if I do capital P and I run that? Well, we don't get anything. Why? Because the field doesn't exist. So we need to make sure that the field name actually exists before we can add this onto our project. So let's go back to lowercase p here, and I want to also type in event data dot destination port. Sweet. So that is good. I also want to take a look at the processes, right? I want to know what kind of process was responsible for initiating that outbound connection. And you might ask, Steven, what if I don't know what the process field name is? Well, that's a great question. What you can do actually is comment out this particular line by adding in 2 forward slashes, run the query again. Let's expand the first event from the top, and let's find where our process lives. So under event data, we do see a process right here, and this lives under the field name of image. And the user is here too, protocol and initiated. Cool. So we know that the process is under image. Why don't we add that into our column here? Type in event data dot image. Let's add in the user as well. And you know what? Let's do the process GUID as well, because that in itself is a hack. And I'll explain why later. But essentially, if you have the luxury of Sysmon data, you can utilize process GUID to identify pretty much all of the activity related to a certain process. Now that we added in those columns, let's go ahead and remove the 2 forward slashes and rerun our query. That is looking really nice. The problem here is that our destination IP contains our domain controller IP. We don't want that, right? We are identifying the outbound connections sourcing from the domain controller. And because we know that the domain controller IP address is 192.168.10.8, let's just go ahead and filter for that. I'll say where event data.source IP equals 192.168.10.8. And beautiful. Now we are starting to see all of the traffic sourcing from our domain controller outbound to other external IPs. Now I am going to sort the time, and I'll do this by typing in sort by time generated, and I'll do this by ascending order, just by typing in ASC. If I wanted to sort it by descending order, I'll type in DESC, just like that. But I am going to sort it by ascending order. Now we can start taking a look at the process and outbound connections. If I go back over to my community post, it says right here, August 26th, roughly 1 a.m. UTC, sourcing from our domain controller. And if I take a look at the 5th event from the top, so 1, 2, 3, 4, 5, this is our first event starting at 1 a.m. Now we can take a look at the image and also the destination IP address. We can see that the image is coming from Microsoft Defender, and the IP address is 52.123.128.14. Is that malicious? Maybe, maybe not. But let's just continue to scroll down and see if we can find anything interesting. And around right here, 1:41:43 a.m., we start to see Microsoft Edge along with the user of administrator. And about 10 minutes later, so right here, 1:51:03, we start to see a process starting from administrator, app data, roaming, Microsoft, Windows, start menu, programs, startup, windows.exe. And this is being ran by our administrator, going out to the IP address of 140.82.113.3 on port 443. Interesting. What the heck is this process? Right? So now that is my next question. What is windows.exe? How did it get there? Do other hosts have windows.exe? How many different addresses does windows.exe reach out to? And are other hosts reaching out to the same IPs? What I'm doing here is scoping out my investigation. I need to understand how many potential assets are affected by this particular binary. And let's see how far this actually goes. Right? If I scroll down here, we can see another IP address reaches out to 8.8.8.8, which is Google's DNS. And yeah, just a bunch of outbound traffic starting from 1051. I'll go ahead and copy this, right click, copy value to clipboard, type in Windows event, which again is our sysmon. And I can say where event data dot process GUID equals, and I'll paste in the process GUID. Now it is currently for the last 30 days. Again, I am going to copy my filter here and let's paste that into our new query, just like that. Now you might be wondering, why am I doing this process GUID instead of not just searching directly for the windows.exe? You can definitely do that, but you might get additional hits from something that's just not relevant. However, if you utilize the process GUID, you are zoning in on that particular process that occurred that we know for a fact called that outbound connection. And you're not only focusing on that particular event ID, because if you utilize process GUID, it would actually search up and tell you what other event IDs were generated based off of that process. Hopefully that makes sense. If we take a look at the event ID here, we do see different event IDs. There is 7, 3, 22, probably going to be a 1 soon, but right now it's only those. However, though, what if I actually just do for the last 30 days? And then let's summarize by event ID. And yeah, we still see the same event IDs. I am going to speed up my investigation just a bit because I don't want this video to last for more than 2.5 hours. I am going to type in where event data contains, and I'll type in windows.exe. Now this might give us some random data that is not related to this particular event/incident, but I am just going to run it just in case. And wow, okay, it is showing the first 30,000 results for the last 30 days. And let's just make sure that these events are what we're expecting here. Now, expanding the first event from the top, taking a look at the image. Oh, look at that. We see this particular executable. Interesting. And if we take a look at the target file name, we can see that it is windows.exe, which is the one that we're interested in. Okay, so this is a new finding here. I can begin putting that into my notes and again, identify what other host might actually have this particular executable. And we can do this by searching the file hash for this or the process name itself. But do keep in mind that those are very easy to change, but it is always a good idea to check. Based off of our previous search, we know that event ID 3, 7, and 22 exist. What I'll do is exclude those. Where event ID is not in, and I'll say 22 was 3 and 7. Now we get event IDs 11, 15, 13, 2, and 12. Taking a look at the timing here, we do have it at 1:50, and there's also a 12:56 p.m. and a 1:06 p.m. Okay, let's expand that. Let's make sure that this is actually related. And if I go into the event data here, okay, so Microsoft Defender may have done something to our windows.exe file. And if I expand the next event, we can see that the value was deleted. Okay, nice. So that kind of answers my next question, which was, is this still running in my environment? And by the looks of it, doesn't appear to be so, because we can see that the value was deleted. What you can also do is remove the not in, and we can search that up. And we will see network activity based off of this particular process. But if we sort by time generated in descending order, where the latest event is at the top, we can see if there are still any network activity coming from this process. Looking at the first event from the top, the last event was tracked at August 26, 2025, 8:09:09 a.m. UTC. Now, if I click into it, and if I look at the event data, we can see, hey, the image is indeed our windows.exe. And if I expand to show more rows, the destination IP is 5.206.224.85 on port 8080. But today, as of recording, which is September 2nd, there are no more network activities sourcing from this process. What this tells me is that this activity likely stopped and it's no longer occurring, at least based off of this particular evidence on the domain controller. For the other computers, we don't know. That is why we need to search across our environment for all of the IPs that this process had called out to. I want to search up the other executable that we saw, which was our gdh7tsv.exe. Go ahead and comment that one out and let's run that. And I'll do a summarize by computer. We can see that the domain controller is the only one here. Now we did make that check in the beginning, but again, habit, it's always good to just double check everything. What we could also do just to make sure we cover our bases is put in our windows as well. And again, just our DC. But if we were to go back to our query, we can now see that the event ID of 1 exists. And I do want to sort this. Sort by time generated, ASC. And now we can follow the chain of events. At 1:50:15 a.m., this particular process generated an event ID of 15. Now, what is event ID 15? Well, if I type in sysmon event ID 15, it says file create stream hash. This event logs when a named file stream is created. And if you read here, it says there are malware variants that drop their executables or configuration settings via browser downloads. And this event is aimed at capturing that based on the browser attaching a zone identifier, aka a mark of the web stream. Cool. In other words, this will tell us when this file was created on our domain controller. Now there should likely be another event. Yes, right here, right underneath it, event ID 11. And if we search out what event ID 11 is, it is file create. So at the same time, 1:50:15 a.m. UTC time, this particular process was created on our domain controller. Within 2 seconds, it was executed. We can see that by the event ID of 1, which is process create. And then eventually it created our windows.exe persistence right here. Now, just to make sure, I can copy the process GUID where event data.process GUID equals. We could take a look at all of the events for that one particular process. Another way of doing this is also taking a look at the process ID and start filtering for that. But I find that by utilizing process IDs, it can get kind of messy and or you might be missing things. So that is why whenever I am working with sysmon data, I always take a look at the process GUID. And every new process that is executed, so your event ID 1, it will generate a new process GUID. And that particular process GUID is going to track all of the activity related to that single process. With this particular demo, it doesn't really show how powerful that can be, but trust me, it is very powerful. So as a hint for you guys, if you're doing some kind of threat hunting or capture the flag scenario, and there is sysmon data, take a look at the process GUID. Now let's just quickly do our scoping check by taking a look at the IPs that our particular process initiated. And just to make sure, actually, I want to see if this process had created any event ID 3s. So I'll type in a summarize by event ID for the last 30 days. And there are no event ID 3s, aka network activity. What that tells me is the windows.exe was the one responsible for those network connections. And we can do a count actually. Count by event ID. And wow, 42,000 network connections. That will explain our bump right here. I am going to search for event ID equals 3. And let's summarize our destination IPs. Type in event data.destination IP. And it says, hey, this is a dynamic type. So make sure to use toString. Okay, I'll type in toString, surround it with parentheses, and let's run that. Now I will sort it. So sort by count. And we see that the top IP is 104.21.16.1. There are 12 distinct IP addresses that this particular process calls out to. We can now perform our OSINT and all of that good stuff. And then from here, we can gather all of these IP addresses, search it across our environment to see if there are any other devices reaching out to this particular IP address. And just as an FYI, in our SOC simulator, we do know that Windows event table only contains our domain controller. However, though, our security event does contain our other computers. So that is what we can also use to identify scope, right? Maybe one of these IPs were able to RDP into one of our many computers via a compromised account. Or what we can also do is take a look at our device tables. We can take a look at the device process events. Do any of the processes contain windows.exe or the other process that we found earlier? And what about device network events? We can utilize this particular table and search across these IPs as well. What we're doing here again is making sure we scope it out. We don't want to just focus on one particular event/incident because we might be missing the bigger picture. However, with that being said, we accomplished our objective, which was to identify that spike. And that spike was due to this binary calling out to multiple IP addresses. And just for your information, if I were to go back to searching for this particular executable, looking at specifically event ID 1, which again is process creation, it will include a file hash for us, which is right here. And if I copy that, head over to virustotal.com, paste that in there, we can see that 57 out of 72 vendors flagged this as malicious, and it is a Trojan. In other words, malware was responsible for our spike in network outbound connections. Now, there is one last thing before I close out this video, and what I did was search for event ID 22. If you recall, with event ID 3, we found the top IP address. And if you do some OSINT on those IP addresses, you'll notice that it is from Cloudflare, which is a content delivery network. So if you were to search that across your environment, it is likely that you will see a lot of hits. Now, what you can do to actually zone in even more into this particular nefarious activity is to utilize the event ID 22. What this event ID will show us is the DNS queries. So if I go ahead and expand the first event from the top, and if I scroll down over to event data, I can see that, hey, this particular process of windows.exe queried for GitHub. How common is GitHub? Is GitHub malicious? Well, it can be, but it is likely going to exist in your environment. Then what can we do? Well, we can't simply block it because that is going to affect availability, nor can we block Cloudflare as well. So instead, what we can do is type in a summarize, and I'll summarize it by toString event data dot query name. So now I want to see the individual DNS queries that this particular process had called out to. And I can see if we go ahead and exclude GitHub and possibly Cachefly, maybe this might exist in your environment. I know for sure GitHub is going to exist, but this one I'm not too sure, to be honest. But nosetu.com and argentumon, I'm not going to pronounce it, but anyways, this particular host name here, this domain, that is what we can use to search across our environment, something that is less likely to exist. Out of curiosity, what is nosetu.com? So if I go ahead and open up a new tab, type in browserlink.com, and if I paste that in, where does that go? Okay, it opens up what appears to be some kind of blog. And you might be wondering, well, why did we see a lot of hits for Cloudflare? That is where we can search up the DNS records of this particular domain, which we can use nslookup.io. And if I paste in our domain of nosetu.com, there you go. We can see a bunch of Cloudflare IP addresses. That is why we saw a ton of Cloudflare IP addresses when we searched for event ID 3. Really quickly, I just wanted to show you what scoping would look like if you were to search across the other computers using the device tables. So I went ahead and created a list called IP, which contains all of the outbound IP addresses that the windows.exe reached out. And then I put in the table name of device network events, where the remote IP is in any of these IPs. So if I go ahead and search this, I could see that, hey, there are actually some computers that reached out to some of these IP addresses, or more specifically, the 8.8.8.8. And that is honestly to be expected. It is Google's DNS. Now, does that mean it's malicious? Definitely not. Because if we expand one of these events and taking a look into the additional fields, looking at the answer, we can see what it was trying to request. And if you recall, none of these domains were the ones that our IOC had requested. So instead, what I did was create 2 additional queries, and I'll go ahead and comment out this one right here. And now I am searching where any of the answers contains our domain of interest. So the not set U and the other one. And this is within the last 30 days. So there were no results found. And what this tells me is that there were no other computers that reached out or queried for these 2 domains. And it will be the same process if you wanted to take a look inside of the table device process events, looking for those specific processes. But again, just wanted to show you what scoping would look like in this particular case. That was pretty fun, and I hope that you learned something new by watching how I investigate an anomaly. If performing investigations really excites you and you want to become a SOC analyst one day, do check out the MyDFIR SOC Community, which again is down below in the description. Inside, you'll find a 90-day SOC Accelerator program which will teach you how to investigate alerts and create reports. You'll also get to apply what you just learned inside of the SOC simulator, where you will follow a SOC process that I built and experience what it's really like to work as a SOC analyst. You'll triage alerts, conduct investigations, manage cases, and create reports. If that is right up your alley, then I really do hope to see you inside one day. Remember to stay curious and do things differently.